Okay, I'm back again. Now we want to go through calculus 2, that is specifically integration. And as you know, integration has different methods of approaching it. We have the first method, which is substitution method, which I'm going to deal with. First one. Okay, substitution. Let me use examples. Maybe I can explain well with examples. Let us use example 1. Example 1 says the integration of 2x, the root of 1 plus x squared dx. Now this one, substitution means you have to substitute, to use a certain value or a certain figure with any letter, maybe for you to substitute, for you to work out easily. Now I can rearrange this equation by writing as integration of root of 1 plus x squared multiplied by 2x dx for easy maybe substitution. Now let me let the value which is inside the root, that is u, to be 1 plus x squared. If this is u, for you to find the u, you have to differentiate this one. Now the u will be 2x dx. That is our du. And as you can see, this du is equals to 2x dx. The 2x dx resembles the 2x dx on the equation, and the u, which is 1 plus x squared, resembles the 1 plus x squared in the equation. Now we can substitute that by and write as integration of the root of u multiplied by the u. Now this root of u, from the knowledge of mathematics, the root of u can write as integration of u raised to power half multiplied by the u. Now you know that in differentiation we subtract the power by what we take the power and multiply by the coefficient of the value or the u. Then the power we subtract by 1, that you have differentiated. But in integration we do the other way around, or the opposite. Now we'll take the power, add plus 1. The answer you get, you divide the value by the answer you get, the power plus 1. That is u raised to power half plus 1 divided by half plus 1. Then this du will give us plus c. This will be u raised to power 3 over 2 divided by 3 over 2, then plus c. You can remove the denominator by writing the reciprocal of it. This is 2 over 3 u raised to power 3 over 2 plus c. But our u was 1 plus x squared. Now this will be 2 over 3 into 1 plus x squared multiplied by raised to power 3 over 2 plus c. And that is our final answer. That is the first approach, the first example on substitution method. Let me take another example, maybe so that we can see how we approach different questions. Example 2. Example 2 is the integration of x over x squared plus 1 dx. Also this one, if you substitute, first of all you have to rearrange it. Someone can say that this is the integration of 1 over x squared plus 1, then x dx. This is the same as just multiplying this x by 1, then it comes back to the original equation. Now we'll let x squared plus 1 to be u. Now for you to find the u, you have to differentiate this one. You'll say that the u now will be 2x dx. From our equation we only have x dx, we don't have 2x dx. Now we'll divide both sides by 2 so you can find half the u will be x dx. This x dx is the same as this one, so you can, if we are substituting, we will substitute this x dx with a half du and x squared plus 1 with the u. Now if I now substitute everything, I'll use integration of 1 over u, because our u is x squared plus 1. Then multiply by this x dx, it is the same as a half du. Now I'll have a half du. But because this a half is a constant, now constant comes out outside. I'll have a half integration of 1 over u multiplied by the u. Now if you integrate 1 over u, you will have a natural log of u. Now this will be a half natural log of u, then plus c. And but our u was x squared plus 1. Now the final answer will be a half natural log of x squared plus 1, then plus c. This is our final answer. Let's move to example 3. Maybe example 3, the first one we have used, we have find a question that comprises of natural, the simplest, or let me say the easiest one. Now let's look at a question that can link us to exponential, how you can integrate the exponential using the substitution method. Now I have an example here. This is integration of exponential raised to power 2x. Now this example of exponential, we only integrated the power of exponential. That is the one that the same thing we did in differentiation. We differentiate the power of exponential. Now here even we integrate only the power of exponential. Now because we are using substitution method, we'll substitute the power. Now we'll say let u to be 2x. That is our u. Now our du will be 2x, not 2x. It will be 2 dx. Yeah, because we're differentiating. This one has the power of 1. If we differentiate this 1 minus 1, it will be 0. Now any number raised to power 0 is 1. Now we'll have 2 dx. If we come and replace in the equation, or we substitute in the equation, we'll have integration of exponential raised to power u, and our dx, our dx, it will be, you divide here by 2, you divide here by 2, it will be a half du is equals to dx. Now dx is a half du. Now we replace here by, multiply by a half du. Now this a half is constant. We must take a half outside. Now we'll have a half integration of exponential raised to power 4 du. Exponential raised to power u du, not 4, u du. And when we want to, now in integration, the constant remains. We'll have a half integration of exponential raised to power u. It is exponential raised to power u plus c. This is multiplication plus c. And our u was 2x. Now the final answer will be a half exponential raised to power 2x plus c. This is our final answer on the exponential. Let me repeat exponential. Exponential, I said, exponential raised to the power. The power is the one that we are integrating. Now if we integrate the power, it means you are going to substitute the power. Now that is 2x. And if you let u to be 2x, now our du will be 2 dx. And our du being 2 dx, in our equation we only have dx, we don't have 2 dx. Now we have to divide both sides by 2 to remain with dx alone, so that we can replace it, or so that we can substitute with the answer. Now this dx will be a half du. If we substitute, we'll have exponential raised to power, integration of exponential raised to power 4 or raised to power u, then multiply by a half du. And this u was 2x. If this a half is a constant, it will come outside. You'll have a half exponential integration of exponential raised to power u du. And this exponential raised to power u, if you integrate, it will be exponential raised to power u. It remains the same because our u doesn't have any power. I say that we are integrating the power. Now this power must have another power so you can integrate, or the numbers can change. But this u, it is constant. Now you'll have exponential raised to power u, then we add c. I will have a half raised to power exponential, and our u was 2x. Now a half exponential raised to power 2x plus c, which is our final answer. Let me look at trigonometry, maybe the one that deals with trigonometric. Let's look at integration of cos 2x dx. This is another example. And cos 2x dx, I can in substitution, maybe I can substitute this to x, the value of 2x, and say let u to be 2x. Now our du will be 2 dx. On the other side, we only have dx, we don't have 2 dx. Now for it to remain with the dx alone, I'll divide both sides by 2, and I'll have a half du is equals to dx. Okay, I have the x with me, and I have 2x with me. Now you can substitute in my equation. It will be integration of cos 2x was u. Now cos u multiplied by the x was a half du. Now I'll have multiplied by a half du. And because this a half is a constant, now I'll take a half outside. I'll have a half integration of cos u multiplied by du. Now, in differentiation, if you differentiate cos, you'll get negative sign. But in integration, if you integrate cos, you will get sign, not negative. Now, integrating this cos u, I'll have half multiplied by, if you integrate cos u, you'll get sin u, then plus c. And our u was 2x. I'll have half sin 2x plus c, which is our final answer. Okay, you can be given it's not a complicated one, but the one that can maybe challenge you. For information, if we are dealing with this trigonometric integration, we only substitute them into cos and sine. Maybe tan, but if you look directly from the table or from the the table that will be given. Now, if I, for example, have been given, this is another example, example 5. If I've been given a question such as integration of tan x, this is integration of tan x dx. Now, from our point of view, we know that tan is equals to sine x over cos x. Now, I'll come and replace this one. I'll write the equation. I'll write the equation as integration of sine x over cos x dx. Writing it like this, I can rewrite it again and say that if you write sine x over cos x, someone else can write it as integration of 1 over cos x sine x dx. This does the same as multiplying this sine by 1 to have it sine x over cos x. Then I'll now start substituting. I'll say that let u to be cos x. If u is cos x, now our du will be negative of sine x. I hope that one we know. That one we know. Cos okay, negative sine x dx. Now, if I want to remain with the, here we only have sine x dx, I must remove this negative sign so that this one can coincide with this one. Removing the negative sign, I'll divide both sides by -1 by -1. Now I'll have negative du will be equals to sine x dx. Coming to replacing the equation, now I'll have the integration of 1 over cos x, which was u, 1 over u multiplied by negative du. Because our sine x dx, it is replaced by the negative du. And negative, it's a constant. Now I can take negative outside, which will be -1 integration of 1 over u multiplied by du. Now this one, 1 over u, if we integrate, I told you that 1 over u, it is the natural log of u. Now I'll have it as -1 natural log of u, then plus c. But our u, what was our u? Our u was cos x. Now my final answer will be -1 natural log of cos x plus c. That is my final answer. Maybe if there is any question, I've dealt with the trigonometric ones, those ones that require the exponential, the ones that requires the natural log, or even the other questions that maybe can challenge you. You can just maybe read from the from the table and try to integrate and solve, so that you can see if you can get the right answers, the one that as compared to the one that is in the table. Okay, me, I've finished my class. That is integration by substitution method. Maybe, God willing, next time I'll be presenting integration using parts. Method of the parts. That one deals with many things. You have a cyclic method. You have reduction method. By parts is maybe broad. Now you can deal with these are simpler one. Okay, let's meet next time. Call me Professor Bill by names. Like, subscribe and share for more videos. Thank you.